Okay, good afternoon, everyone. Yeah, for this revision class, we'll be looking at the revision for the assignment 1 and then the assignment 2. We're going to look at the solution, and also I'll be presenting a hint on how we draft the marking scheme so that you know how to present your answers. And the emphasis is that it's better to supply more answers than to give limited answers. Okay, especially when you're giving an open-ended questions, you should supply as much as you can. And if you're given a question to solve, because I noticed that in one of the questions, some persons just, because I used the word list in the question, we just listed without showing our working. It's best to always show your working when you're giving assignments, because you don't know where the score is actually being allocated to. So it's best to supply more information than to give less information when you have access to such information. Okay, so let's begin today's revision class by looking at the first solution to assignment 1. So we'll have the assignment 1 before us, and we are asked to solve chapter 1, exercise 11 and 4, then write explanation on descriptive and explanatory model. All right, so I have the questions for question 11 and question 34. Sorry, I said 11 and 434. Okay, and I also included some questions that we should practice. Now, the essence of this question is that they are so brief a question such that they're the kind of question you can solve within a minute, the kind of question you will see in multi-choice questions. Okay, if you have to choose options, these are the kind of questions that appear in such options. So that is why I said you should practice them so that you get familiar to questions of this format. All right. So now, each of the questions for the assignment 1 has 10 marks. So the assignment 1 is just a 30-mark assignment, which will take certain ratio of the assignment to make up our cumulative assessment. Okay. So now the idea is just to show you how we draft our marking scheme. We'll have two things to give an explanation for. One has more explanation than the other in terms of content, but really I didn't present all the content as we ought to, but I'm just using this as a template to how we mark questions like this. So what we do is we look at keywords, explaining the concept in the language of the course, because we'll have explanatory and descriptive model in several fields of study. So you have to be sure when you go to Google to browse open-ended questions as explanation or explanatory model or descriptive model, to pick that which apply to physics, because we have to narrow our answers to physics concepts. Okay, so divided this into 5 marks. 5 marks goes for the first description, and then 5 marks goes for the second description. So for the second question as well, which were asked to list the items in order of decreasing speed from greatest to the least. And then we're provided with certain parameters. Number 1, a wind up toy car moves 0.15 meters in 2.5 seconds. The second one says a soccer ball that rolls 2.3 meters in 0.55 seconds. And the third says the bicycle that travels 60 meters in 0.075 seconds. And the number 4 says a cat that runs 8 meters in 2 seconds. We should arrange the word, because some of us give our presentation in the opposite direction to the question. You are to present your answer in terms of decreasing speed, that is, you are going from highest to the lowest. All right, so we'll have 10 marks for the question, and then we divided them into several points. We have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1 mark for each expression. But I noticed that when we're going through the solution submitted, because we use the word list, some persons just listed the solution like this without showing the working. How did they arrive at what they listed as the final answer? You must have done the working somewhere. It's really of best interest to present the solution, because we want to see how you arrived at the answer you got. So for those of you that did this, ordinarily, it means out of 10 mark question, you just got 1 mark. But because I didn't have to specify, or I have not explained this before, I'm not going to take it out or mark it exactly how the marking scheme says. I'm going to have to consider that, okay, making an assumption that you did it somewhere, but didn't present the answer. But this will not always apply in case of future time. If you are asked a question and you are to submit your solution and there is no specific instruction as to if you should show the working or not, it's best to show your working. Okay. So this is not right. If you divide 2.3 divided by 0.55 should give us something about 4.2. Yeah, thereabout meters per second, and not 7, sorry. That was a mistake, okay? So we took the first one, they gave us the distance in meters, and they gave us the seconds. And we are looking for decreasing speed. So our V, which is our speed, is equal to distance over time, and we got yes, we got this 0.06 value. We did that for the second one as well. We got 4.2 meters per second. And if we do that to the third, we will get 8 meters. And we apply the same formula to the fourth instruction, and we got 4 meters. So we have to arrange in terms of decreasing order, that is going from highest to lowest. We see that the first one with the highest was, that is what we mean by number 1, which is 3. The next highest value is this number 2, which is the II. The next, which is the third, is I4. And then the least is the I. So we see that I, in terms of velocity, II is greater than I2, greater than I4, greater than I, which is 3 is greater equal than 3, or speed in the scenario of the third is greater than that of second, and then the fourth, and the least is the first scenario supplied. So that's how we got the answer for that. And the third question, which also was given 10 marks, says a circular test track for car in England has a circumference of 3.2 kilometers. A car travels around the track from the southmost point to the northmost point. The first question says, what distance does the car travel? And the second one says, what is the car's displacement from its origin? So if we picture the scenario described, the test track is circular. Okay, and this is your north, south, east, and west. Now, the car traveled from southmost, that is from the south, to the northmost point. So the car moved this way. Now we're asked to look for the distance that the car traveled, right? And the second one is saying we should look for displacement. So we know the difference between distance and displacement. Remember in class when we solved, when we're looking for distance, displacement was when we first of all introduced the concept of vector to the lecture series. And we mentioned that when we want to look for displacement, we don't care about the details in the journey. We just care about the start to the end. Okay, so that is the difference. Why distance cares about the details in the journey, the displacement does not. So this move half the circumference. So if the circumference of the circle is given to be 3.2 kilometers, we just divided it by 2 because the distance covered just half of that circumference. So we got 1.6 kilometers as our answer. Okay. So the second one says we should look for the displacement, which is the diameter in this case of the circle. All right. So because we have information about the circumference, we want to obtain the distance, what we have recognized as displacement, which is the diameter of that circle from the information supplied. So the circumference formula for circumference of a circle is 2 pi r. And the diameter of that circle, because we know r is radius, is 2 radius. So diameter itself is 2r. So that means we can actually replace with d, which is the displacement that means the diameter of a circle. Okay. So replacing that in this equation, we get that the circumference of a circle equal to pi d. So to find d, we make d the subject of formula circumference over pi. Circumference is given in the question, which is about the only parameter supply. Pi is a constant. We have the final answer to be 1.019 kilometers, which is approximated to 1 kilometer. Okay, we'll see how we shed the 10 marks. Formula takes 1 mark, and then we see the expression 2 marks here, 2 marks here. Because it's 10 marks, we give A part 5 marks and B part 5 marks. So we didn't have to. The formula also takes 1 mark in the B case, and 2 marks for expression, 2 marks for the final answer. Okay. So most of us also got the answers. So it just indicate the solution for number 1 that some of us did not show are working. And then here also, some of us did not even bother to say so much. Apart from what was on the test, we did not try to add additional information, but we're not going to penalize anyone for not adding additional information, okay? So we move to the simple calculations that can appear in multi-choice question because it takes just 2 minutes or a minute to solve. The practice question says it takes Harry 35 seconds to walk from minus 12 meters to minus 47 meters. You know what minus means to this kind of description, okay? So it tells you the direction of the walk. So what is velocity? Velocity is simply the change or distance travel over time, which is changing S over change in T. S final to S initial. The S final is Harry moved from, this should be the start, to the finish. So we'll have S final minus S initial. And then we'll have 1, the velocity of the movement is minus 1 meter per second. So if it comes in a kind of multi-choice question, you see it's something you can just solve in 2 minutes and you just pick your option or answer. Okay, so the same kind of question, the same pattern. A dog trots from the distance minus 12 meters to 3. So now if you have the idea of number line, you already have an idea of what that distance is. So, but we'll have the formula we're following is going from this to this. So the final distance minus the final position minus the initial position, which is 3 minus 12, which gave you 3 plus 12 to be 15. 15 divided by the time supplied. We covered this distance. Within that time, we have 1.5 meters as our answer. Okay. So this part, that's the question 20. It's just you've seen several kind of this significant question. The lab quiz, we had most of this kind of question in our significant figure question for the multi-choice. How many significant figure does each of the following number have? Now, whenever we want to discuss significant figure, we want to keep 3 things at the fingertips. We want to keep in mind the trailing 0, the leading 0, and the decimal effect. That is the trailing 0 effect on the significant figure, the leading 0 effect, and the decimal effect. Okay. Whenever we have a non-zero digit before a number, and then you have zeros in between, you don't count those zeros as trailing zeros. Let's take, for example, the kind of number before us. We see these zeros in the section B. These zeros are leading zeros. Okay. Now, for leading zeros, whenever there is decimal, the leading 0 will not count, but the decimal point makes the trailing zeros count. Okay, so for the first case, we have the non-digit, non-zero digit, because we'll not count the trailing 0. We now have the answer to be 3 significant figure. For the B, we will not count the trailing 0, but we'll count the leading 0 because of this decimal. So we have 1, 2, 3, 4 significant figure. And for D, the start of the number itself is a non-zero digit. So zeros in between will count. So we'll have 1, 2, 3, 4, 5 significant figure For the last one, which is expressed in terms of scientific notation, we focus our significant figure count on this side, not on the power side, because power side can be taken as the leading or trailing zero. Okay, so we have in this case 3 significant figure. Okay, so you remember our example in class when we're talking about significant figure. If you have 300 and then 300, how many significant figures in this one and how many is in this one? Because of the decimal here, that's what I was saying, that decimal in a figure changes the significant figure, helps define it. Decimals in a figure, whether it's appearing in front or at the back, it's going to make the trailing zero to count, while the leading zero would not count. So we'll have in this case 3 significant figure, but in this case we will have 1 significant figure. This one has the dots that help to define or make the trailing zero to count, but this one does not. So if we have the standard form, something like this, for example, when you're asked how many significant figure is this, because of these dots, like we said, the leading zero will count. So this is 2 significant figure. But if it is something like this, this will be 1 significant figure. Okay, and if it is something like that, 4.0 times 10 raised to the power 3, it is 2 significant figure. So you see what the significant figure or the decimal is doing to the figures we count when it comes to leading or trailing zero. The decimal just changes everything. So we'll be meeting a variety of this kind of significant figure questions, okay? As we move on in the course and in the test, and we keep meeting it, we will keep interacting with significant figure till the end of the course, okay? So that's the last set of the question for assignment 1. Feel free to send me a mail, text me your question through mail in the Moodle chat. Use every media possible to ask your question. And if you have any question about the test as well, which will be coming up on the 13th of October, which is on Wednesday, coming Wednesday, you are free to ask. I'll be uploading the instruction of what the test environment and criteria will be. I'll also upload the formula sheet. If you have any suggestion of a formula we should add on the sheet or we should remove, or a correction on the sheet, you just let us know so that we'll modify that and give you the right copy for the test, okay? Thank you so much. So we'll move to the second solution for assignment 2, which we'll be sharing soon on the screen. Okay. 1 moment. Stop sharing. Want to share the second solution.